This is once again haribabuprasad Damarla. In continuation to earlier presentation on digital switching, we will continue our discussion on digital switching. This is the part 4 in series. In earlier parts, we have discussed time switch and we have seen the two-dimensional switching also, where the space switch and time switch, they are used together in a combination. Out of different combinations, we also understood that TST, time stage, space stage and time stage. The TST model is the best available model for digital switching. In this session, we will try to understand the concept of TST in detail. As the name suggests, in a TST network, there are two time stages separated by a space stage. Simultaneously, let us look into the diagram also. So, in this TST network, in the input you have time switch or time stage, and output also you are having time switch. In between is the space switch. So that's why it is known as TST network. The time stage carry out the function of time slot changing, whereas the space stage performs highway jumping. So the time stages, either in the input or in the output, they perform the time slot interchange function, whereas the space stage in between the time stages in the incoming and outgoing, it performs PCM, jumping or change of PCM. Let us consider a network having n input and n output PCM highways. So we are considering this network with n input PCMs, n output PCMs. Each of the input and output time stages will have n time switches, and the space stage will consist of n cross n cross point matrix. So this input time switch or the output time switch will have n switches, whereas the space switch will have n cross n cross matrix, cross point matrix. The speech memory as well as the control memory of each switch, time switch, and each column of control memory of the space switch will have m locations corresponding to m time slots, 32 in each PCM. So time switch will have both speech memory as well as control memory. So similarly, the space switch will have m control memory locations. So the number of memory locations either in the input time switch or in the output time switch, or in case of space switch, we'll have m memory locations. In case of time switch, memory locations will be there for speech as well as control. In case of space switch, you will have m memory column locations. So m depends upon the type of the PCM or the hierarchy of the PCM that you are implementing. In case of 30 channel PCM with 32 time slots, the memory locations are 32. In case of 24 channel PCM adopted by Americans and Japanese, we will have 24 memory locations. So with the help of TST network, it is possible to connect any time slot in the incoming PCM to any time slot in the outgoing PCM. With the help of this TST network, so you can connect any time slot in the incoming PCM to any time slot in the outgoing PCM. Now we will continue our discussion on TST network. In the case of local exchange, the network will be folded type. That is, the incoming PCM highways are connected to outgoing PCM highways via a suitable hybrids. So we deploy hybrids, and the network, in case of local exchange, it is a folded type. Whereas in case of transit exchange, the network will be non-folded, having complete isolation between incoming PCM highways and outgoing PCM highways. So when you consider the transit exchange or trunk automatic exchange, so here the incoming PCMs and outgoing PCMs are isolated and the network type is non-folded type. However, a practical local exchange will have a combination of both types of networks, folded and non-folded. So theoretically speaking, the local exchange is folded and transit exchange is non-folded, but practical switches will have a combination of folded and non-folded. For the sake of explanation, let us assume that there are only four incoming and four outgoing PCM highways in the network. So for this network, so we are taking one example for explanation purpose, which got four incoming PCMs and four outgoing PCMs. Hence, there will be only four time switches in each of the time stages. So in time stages, therefore, you will have four time switches because the number of inputs are n PCM, 4 PCMs, n is equal to 4 PCMs. And the space switch will consist of 4 by 4 matrix. So incoming trunks are 4, outgoing trunks are 4, and the stage will consist of 4 by 4 matrix. Let us consider 4 by 4 matrix means it will interconnect 4 highways to another 4 highways. Let us consider the objective of connecting 2 subscribers through this switching network of local exchange. So we want to connect 2 subscribers through this switching network, and we consider this network as a local exchange. Let us assume that the central control assigns TS4 on highway 0 to the calling party and TS6 on highway 3 to the called party. So since we are considering there are 4 PCMs for incoming and outgoing also, so we have 4 PCM highways. So generally we give the numbering from 0 to 3 for 4 highways. That is highway number 0, highway number 1, highway number 2, highway number 3. Further we will continue our discussion. The speech samples of calling party have to be carried from TS4 of incoming PCM highway 0 to TX6 of outgoing PCM highway 3. So the calling party is entering through highway 1. The information of the calling party or the speech of the calling party is available in TS4, and we have to switch the calling party's speech to the called subscriber in highway 3, this one highway 3, TS6. So outgoing PCM 4, time slot 6. The speech samples of the called party have to be carried from TS6 of incoming highway 3 to TS4 of outgoing highway 3 with the help of the network we are considering. So in case of called party, so his speech in TS6 highway 3 is to be connected to TS4 of highway 0. The central control establishes the path through the network in 3 steps. 3 different steps are involved for transferring of the information and connecting the call. To introduce greater flexibility, it uses an intermediate time slot TSX, that is TS, in our example TS10, which is also known as internal time slot. So to switch the speech of the calling subscriber on highway 0 to called subscriber on highway 3, outgoing highway 3, TS6, so we utilize what is known as internal time slots, that is TS10. Why this internal time slot is required? This because this first stage is time stage, so it changes the time slot TS4 to TSX. X we are assuming as 10. So this 10 will be switched to the TS10 in highway 0 is switched to highway 3 TS10. Then the output also is a time stage. Here also it changes the time slot. So the time slot is changed from TS10 to TS6. This is one path. Because this TS10 and in the other reverse path from call to calling subscriber also we will have another time slot TS11. These two time slots are internal to the network, within the network. They are known as internal time slots. The three switching steps for transfer speech sample of the calling party to the called party are as under. So first we are considering the transfer of speech sample from calling to the called subscriber. This is the calling subscriber. Here it is the called subscriber. How the switching takes place from here to here, we will study in 3 steps. Step 1, input time stage. Here we have input time stage. Here what is the mechanism? TS4 highway 0 to TSX highway 0. So here this incoming time switch shifts the information from TS4 to TSX on the same highway. X we are assuming as 10 as shown in the diagram. So the input time stage switches the time slot from TS4 to TS10. That is the step number 1. In the second step, you will encounter with the space switch. So step 2, space stage. So this space stage, it shifts TSX X, that is TS10 of highway 0 to TSX, TS10 of highway 3. So this will shift to highway 10 on the same TS10 because the space switch will not affect the time slot interchange. Its business is only highway jumping. So from highway 0 to the information is transferred to the same time slot on highway 3. Next, we have completed first time stage, input time stage and space stage. Then we have come to the output time stage. Here what happens in the step 3, output time stage OT. Okay, these are the OT1, OT2, OT3. Output time stage, what it does, it will shift the TS10 of highway 3, this one, to TS6 of the highway 3. So same highway 0, 1, 2, 3. So we shift to TS6. That means the speech of the calling party is transferred to the called party via highway 0 to highway 3 and from time slot 4 to time slot 6. Further, let us continue our discussion. As discussed in the previous slide, the message can be conveyed only in one direction, that is calling to called party, through the path what we have discussed. One way only we have discussed. But in practical scenario, calling party speaks to called party and called party speaks to the calling party. So we have to establish the second path also, that is from called party to the calling party or called subscriber to the calling subscriber. For that purpose, another independent path to carry the message in the other direction, that is called to calling party, is also to be established by the central control to complete the connection, assuming the internal time slots to be TS10 and TS11. The connection may be established as shown in the figure. So calling to called already we have discussed. Now the other direction we are discussing from call to calling subscriber. So he enters, let us assume, on highway 3 in time slot 6. So here the time stage shifts his speech to time slot 11. Then you have space stage which shifts the highway from highway 3 to highway 0. Of course, time slot 11, the internal time slot remains the same, either it is highway 3 or highway 0. Then we are having the outgoing time stage. Here the time slot is interchanged. For easy understanding, we are not changing the highway. From highway 0 time slot 11 to the speech is transferred to the same highway 0 time slot 4. So this is the path for call to calling subscriber, like this. So both way communication is established. Further we will look into TST network. Let us now consider the detailed switching procedure, making some more assumptions for the sake of simplicity without making it too much complicated. In a simpler manner, we will try to understand the detailed switching procedure. Though practical time switches can handle 256 time slots in parallel mode, let us assume serial working and that there are only 32 time slot in each PCM. So earlier we have studied that practical switches, they adopt this parallel mode, That means you are increasing the capacity of handling from 32 to 32 into 8 times. But for easy understanding, we will consider serial working only. So that means in a 30 channel PCM, you will have only 32 time slots. Accordingly, the speech and control memories in the time switches and control memory columns in space switch will contain 32 locations each. Since we are assuming it as a serial working and we are also considering it as a 30 channel PCM with the 32 time slots. So when you look into the number of speech and control memory locations in time switches, you will have 32 locations. In case of space switch, you will have control memory columns. So which will have 32 memory locations. In time switch, you will have both speech and control memory locations, whereas in the space, you will have control memory columns with 32 locations. Further, here you look into the total setup drawing. Let us go through the contents step by step. To establish the connection, the central control searches for free internal time slots. First, the central control will search for the free time slots. These time slots are also internal time slots. We assume the internal time slots as TS10 in one direction and TS11 in the other direction. Let us assume that the first available time slots are TS10, that is internal time slots, are 10 and TS11 as before in the earlier example. To reduce the complexity of control, the first time stage is designed as output control switch, whereas the second stage is input control. So we have seen the time stages can be input associated control or output associated control. So here in our TST network, we design the network in such a way that the incoming time switch, this one, the incoming time switch is of output control, whereas the outgoing or output time stage is of input control. The control is based on the inputs, that is on writing here in the output side. In the input side, it is the control is exercised on reading. Writing is in sequential order. Let us go through the contents. Since the first time switch is output control, the writing is done sequentially. So writing will be done sequentially, one after the other, 0 to 31. Hence, a sample arriving in TS4 of incoming highway 0 is stored in location 4 of speech memory incoming or input time switch or of 0, highway 0. Incoming time stage, so speech memory, incoming time stage 0, 0 highway. Here in the TS, you are getting the samples from the calling subscriber on TS4. So this information is stored in the memory location 4, 0, 1, 2, 3, 4. Okay. It is read out on internal highway 0 during TS10 as per the control address sent by the control memory IT 0. So this is control memory incoming trunk 0. Here the output is read based on the control functionality in time slot 10. because we have associated the internal time slot we have considered as TS10. So when then memory location 10 gives direction that the information available in speech memory location 4 may be read onto the highway 0 TS10. So this is how it approaches the space switch as inputs. Further we will look. In the space switch, during this internal TS10, the cross point 0 in column 3, so this is TS10, okay? The cross point 0, this is the cross point 0, this is the cross point 0 of control memory space switch column 3. This is the column 3 because you are switching the highway to highway 3. So this one. In the space switch during the internal time slot 10, the cross point 0 in column 3 is enabled as per the control address sent by the column 3 of control memory space switch and thus transferring the sample to highway 3. So as per this direction, so available in location 10, highway 3. So the highway 0 is switched to highway 3. This is highway 0, this highway 1, highway 2, highway 3. Since it is a space stage, there is no change of time slot. The second time stage, that is about this. The second time stage is input control and hence the sample arriving in TS10 is stored in the location 6 of the speech memory outgoing trunk 3, speech memory outgoing trunk 3 as per the address sent by the control memory outgoing trunk 3. This sample is finally read out during TS6 of the next frame and thus achieving the connection objective. So for this time switch, the speech is coming on highway 3 time slot 10. Our objective is to send the information on outgoing trunk 3 time slot 6. So here it is input control. This stage, the output stage, we assumed as input control. That means since we have to send the information to time slot 6, so we write the information. So this will exercise a control on the speech memory or buffer memory to write the information on this memory location 6 and it will be read out in the next cycle on TS6. That is how it is sent on TS6 highway 3. Because the time slot 10 has come, that means it has to wait from time slot 10 to time slot 31 in the existing frame, and in the next frame also it has to wait from TS0 to TS5, and next on TS6 only it can send in the next second frame with reference to the first frame. So this is how the incoming speech from the calling party is transferred to time switch and space switch and the output time switch to TS6 highway 3. Further we will continue. Similarly, the speech samples in the other direction, that is from the called party to the calling party, are transferred using internal time slot TS11. So when the called part subscriber is speaking, okay, he speaks on time slot 6. So the information is coming on highway 3. This is the highway 3. Highway 3. Then on time slot 6. Since it is output controlled, the incoming time switches are input time switches are output control. So the information is written in sequential way in the speech memory. Where it is written, since it is time slot 6, so it will be written in the memory location 6. So because it is to be transferred to internal time slot 11, TS11, when the control memory 11th location, the address of the speech memory location 6 is furnished. So the information from speech memory location 6 in time slot 11 is transferred. Then when it goes to the space switch, this one, so here highway jumping takes place. So this highway from 3 to highway 0 takes place on the same time slot. In the output side, you have the time switch, which is input control. So while writing itself, the information is written in the 4th location, so that the information as per the directives of the control memory, it can be sent on TS4. So this is the path for calling to call. From call to calling, like this. This one. So now we have seen how the calling party speech is transferred to called party, and the called party speech is transferred to the calling party by utilizing the TST network and also utilizing the internal time slots, for example TS10 and 11 in our drawing. Now there is another concept known as N-stage network. So though we have studied or discussed in depth about the most popular TST network, their derivatives. TST network is having only 3 stages. Okay, but there can be N stages also, as the traffic requirement increases based on the design aspects. Let us look into the N-stage network with some examples. A TST network is a 2-dimensional 3-stage network. We know it is a 2-dimensional network. TST is a 2-dimensional network. Why we are using space stage as well as the time stage. But it is a 3-stage because we have 2 time stages in the input as well as in the output, and in between sandwiched is the space, 3-stage network. There are higher capacity switches with more than 3 stages. So there can be more stages also, but they are all 2-dimensional only. They use space and time stages together, but number of stages may be more than 3. They are known as N stages. There may be 4 stages, 5 stages, 6 stages, and so on. Such networks are generally classified as N-stage networks. However, they are also 2-dimensional networks with more stages. So why they are 2-dimensional even with N number of stages? Because they may be using either space stage or time stage, and together. Space and time stages are used together irrespective of the number of stages. Some examples are furnished below. Here they have given the system name, configuration, the traffic capacity in Erlangs, and the maximum number of trunks it can handle. So there is one exchange known as E10B developed from France. So it follows TST configuration. So its traffic handling capacity is 1600 Erlangs. So it can handle up to 3600 trunks. Number of trunks it can handle is 3600. Next, we have another exchange, that is number 4, ESS of USA. So it follows this configuration, T4S followed by T. So here space stages are 4 time stages in the input and output. So it can handle a larger capacity, traffic capacity, that is 47,000 Erlangs, and trunks it can handle 107,520. Then we have C dot max XL. C dot stands for Center for Development of Telematics. So it is developed in India. So it also follows simple TST architecture, but it got, when compared to E10B, it got very high traffic carrying capacity, 16,000 Erlangs, and it can cater up to 40,000 trunk lines. Then we have another system by name DMS100. It is folded type. Folded means local. Canada, it is developed in Canada. It follows TSTS architecture. So it can handle the traffic of 39,000 Erlangs, but trunks are 61,000. Then we have one system, that is system 12, developed in USA, so which is having more number of stages. Let us go through these stages: TS, 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 and TS. So many stages. So its traffic carrying capacity is 25,000 Erlangs, and maximum number of trunks it can equip or take care of is 60,000. Then we have one more popular system by name NIAX 61, developed in Japan. So it follows TSST. So 2 time stages sandwiched. In between is 2 space stages. So it can handle the traffic of 22,000 Erlangs. And on the other side, it can handle the maximum number of trunks to an extent of 60,000. Thank you. If you like my video, please subscribe to my channel and also give a like. Thank you.